This video is the review for Unit 2. So this unit dealt mostly with proportions and more specifically proportions as graphs, tables, and equations. So the first question we're going to be asked is to select at least one of these graphs and explain why it is not proportional. So for a graph to be proportional, we need two things to happen. We need, first, it has to go through the point 0, 0. So number 1 does not go through 0, 0. Actually, number 2 does not as well. Number 3 and number 4. None of these go through 0, 0, so that is one reason why none of these are proportional. The other thing that must be true is it must be a straight line. So 1 and 4 are straight lines, but since they're not going through 0, 0, that's why they're not proportional. 2 and 3, they are not straight lines, so those are definitely not proportional. So on to the next slide. In this next question, interpreting graphs of proportional relationships, the two lines both represent the distance over time that two cars are traveling. Which car is traveling faster? And explain how you know. You can sketch the image to support your explanation. So if you want to show how you know, one really easy way to tell is, here's my time. I'm going to use that as a guiding line. So if I draw my time here, and it's supposed to be a nice straight line, and we look at the distance that each one has gone after that same amount of time, B has gone farther than A. So B's distance is farther in the same amount of time. So which car is traveling faster? It would be B. Now, there is an easier way to tell. There's a specific word that we can use called steepness. B is steeper than A, so B is going faster. I think that's the easiest way. So I would have selected B, and then on your explanation, you can just say B is a steeper line. So comparing two lines is pretty simple. It's usually obvious which one is steeper. So the steeper one in this case is going faster. Okay, on to the next slide. Here our graph shows the cost in dollars of W pounds of peanuts. This is a proportional relationship. So it is important they tell you it's proportional. If they don't tell you it's proportional, they may use words like constant rate or the same speed, something along those lines. So we want to figure out which one of these statements are true. The first thing I want to do is I'm going to label my axes. So here on the bottom is my W. This is the pounds. And then my other one, I'm going to zoom that in a little bit so I can see. The other side, that is my cost. Okay, so they're telling us that here we have 7 pounds costs $17.5. One good thing to start if you're not sure where to go is let's find the constant of proportionality. And one thing that we've said a lot is constant of proportionality is just y divided by x. Y divided by x. Y divided by x. Just get that in your head. Constant of proportionality is y divided by x. So if we do that on our point, it's 17.5 divided by 7. All right, and when we go to calculate that out, that is 2.5. That is our constant of proportionality. Now, understanding what constant of proportionality is an important concept here. Constant of proportionality, or unit rate, is just how much of something, how much of one of something. So if we had 1 pound of peanuts, that's going to cost $2.5. Okay, so that is what the constant of proportionality is. It's when we have one of our x value, it's how many of our y values. If you want to take a look at that on the chart or on the graph, for 1, it would give us 2.5. Okay, so we're going to go through and look at our questions, which one could be true. And 2.5 pounds of peanuts cost $1. That's not true. If we were to look at 2.5 pounds of peanuts, so here's 1 pound of peanut. 2.5 pounds of peanuts are way up there. So their cost is going to be more than the cost of 1 pound. So this one does not make sense. That is not an option. Now, 1 pound of peanuts costs $2.50. That is true because that is our constant of proportionality. Okay, now the next one is 5 pounds of peanuts cost $12.50. We're actually not sure about that, but we do know our constant of proportionality is 2.5. So if we multiply 5 by 2.5, we get 12.5, so $12.50. So that is also true. Now 9 pounds of peanuts. Same thing, we can multiply our 9 by our constant of proportionality, and we can see if that is true or not. When I multiply that, that says that is 22.5, which is not 19. So that one is not true. Okay, the last question is the point 4, 10 is on the graph. So we're just going to take our 4 and multiply it by 2.5. Does that equal 10? Yep, it does. The point 4, 10 is on our graph. So this one would definitely be a true statement. Another good way to organize your information, and I did not do that the best here, but I'm going to erase everything for a second. And I'm going to show you one thing that you could do if you are definitely stuck. It is setting up a table. So let's say here, I have my table. I know that 7 pounds is 17.5. So with that, we found our 1 pound by finding our constant of proportionality. And then we're just finding the other pieces that fill in our chart. So using a chart can be helpful to us if we are stuck. So another way to organize the information if you needed to. Okay, I might have skipped a slide, I'm not sure, but if I did, go on to the slide that is on the screen right here so we can talk about it. We want to decide if the proportional relationship, which one of these equations represents a proportional relationship. So Kieran walked at a constant speed. So he walked 1 mile, that's our distance, in 15 minutes, that's our time. Which of the equations that we have here represent his distance in miles? So if we do have our distance, we would multiply our distance by 15 to get to our time. So that means my time here is equal to 15 times my distance. Now you'll notice that one's not an option on our graph or on the things that we have. So that means we're going to have to go backwards. We have our time here and we want to go that way. What would that proportion be? Well, instead of multiplying by 15, we're going to just take our time and we're going to divide by 15. So that option is D, because 1/15 is the same thing as dividing by dividing by 15. So there we go. So the chart is the best way to kind of organize your brain in these situations. All right, same thing on this one. The table shows the weights of bananas at a grocery store. Complete the table so that there is a proportional relationship between the number of bananas and their weight. Now, there's a step here that they didn't do that I think would be super beneficial to us. And that is, I'm going to clear that submit button just because I don't want to see it right now. But what if I took my graph and made one more row here? I found what happens if there is one of something. That is going to be our constant of proportionality. So to find that constant of proportionality, I'm going to use the row that I have. This 5 and 1.6. So here's our x, here's our y. To find our constant of proportionality, we just take our y value and we're going to divide by the x value. And we get 0.32. So 0.32 is our constant of proportionality. Now we need to just kind of fill out the rest of our chart. So this is the thing that we're multiplying by each time. So if we want to go from 3 to here, we would just go 3 times 0.32. And that gives us 0.96. And if we had 12, we would multiply 12 by 0.32 because that's still our constant of proportionality. And we get 3.84. So that is our table filled out. So that means if we're going to type this out, first we find the constant, and then second we multiply the constant by 3 to get 3's weight in pounds, and 12 to get 12 weights of pounds. All right, this next slide is a quick little problem. The equation S equals 50 plus 45W represents the savings after, or S after W weeks. So we just want to find if it's proportional or not. And in order to find out if an equation is proportional, very simple, there can only be multiplication. It's going to always be like y equals your constant times x. So because we have adding, this is not proportional. And that's all you need to say. It's not proportional because we are adding the equations. Okay, this one is also pretty simple. We just want to find which table is proportional. So remember, proportional is just y divided by x. We're going to find the constant of proportionality here and see which ones are worked. Now, I'm not going to divide the 0 by 0 because that's really nice. It's starting at 0, 0, so we're good. Then here we're going to go 4 divided by 2 is 2. 9 divided by 3 is 3. 16 divided by 4 is 4. So these are not the same. So this is not proportional. Okay, let's look at the next one. So we've got here, starting at 0, 0, that's good. Here we have 6 divided by 2 is 3, 9 divided by 3 is 3, and 12 divided by 4 is 3. So those are all the same. It's going through 0, 0, so this is proportional. Okay, the next one is pretty simple because it's not starting at 0, 0. So that's really bad. But also, if we were to look here, 6 divided by 2 is 3. 3 divided by 3 is 1. And 0 divided by 4 is 0. So these are also not the same. So this just in general is not proportional. Okay, and our last one, also it's not going through 0, 0, so we already know it's not proportional. But we can double check. 12 divided by 2 is 6. 15 divided by 3 is 5. 18 divided by 4 is not pretty, it's not clean, so I know that this one right here is not proportional. This is kind of nice to know. the easiest thing to do is just find all the constants of proportionality. It is a good idea to check if you have 0, 0. Not all of these are going to have 0, 0 or any point with 0 on it to be like make it super obvious. But just so you know, that is something you can look at. Okay, what they want you to do on the slide is if they give you the situation, it's 5 cups of strawberries for every 2 cups of bananas. And we have the line that represents the relationship between strawberries and bananas. So it's 5 cups of strawberries for every 2 cups of bananas. So our bananas is going to be the x-axis because there's less bananas than there are strawberries. That's how I could tell. Okay, so my x-axis is bananas, and my y-axis is the amount of strawberries. So if you look at the point 2,5, that is also on there. That means for every 2 bananas, there are 5 cups of strawberries. And if we were to switch that and say it's 5,2, 5,2 is not on my graph. So it has to be bananas first and then strawberries. So continuing on with our problem, a recipe for a smoothie that has 5 cups of strawberries for every 2 bananas, the line represents the relationship between the amount of strawberries and the amount of bananas. We have this point, 1, 2.5. We're going to write an equation, but there's one thing we have to do before we actually write the equation. We have to find our constant. And this is going to be very important. Our constant of proportionality is the y value when x is 1. So when x was 1, we had 2.5. So that means our constant of proportionality is the 2.5. So if we write our equation here, it's very simple. Y equals whatever our y value was times x. Okay, last thing is, what does the point 1, 2.5 tell us in terms of this in the situation? It is that for every 1 banana, we need 2.5 cups of strawberries. Sorry, 1 cup of banana, we need 2.5 cups of strawberries. Okay, now that is also our unit rate. So for every 1 banana, it's 2.5 cups of strawberries, or we also could call that our constant. Constant of proportionality. There we go. That's what is going on at that point. Okay, here we have a hot dog eating contest where Andre ate 10 hot dogs in 3 minutes and Jada ate 12 hot dogs in 5 minutes. Now we have the 2 points on our graph and we need to decide which one is Andre's and which one is Jada's. And we're going to draw the lines and label them. So Andre ate less hot dogs in less time. So he's the one that's to the left and down a little bit because he is not quite as much time has gone by. So we know that this is Andre. Okay, Jada ate 12 hot dogs in 5 minutes. So this one would be her because she's a little bit more hot dogs, but more time also. So this is Jada. Okay, they are both going through the origin because at 0 minutes they have eaten 0 hot dogs. So there's our graph, and that's what we've got it labeled. Yep, we've answered every question that they want. So let's go on to the next slide. Okay, so if we go back to Andre and Jada here, Andre is the red line, Jada was the green. Now, Andre, I'm just going to label an A. His time in 1 second, we find that constant of proportionality, it's 10/3. So that means Andre's time was, for 1 second, we had 10/3. So his constant of proportionality is 10/3. If we want to write his equation, they want us to use T in times and H for the number of hot dogs. So the number of hot dogs Andre is going to eat is 10/3 times the time. And if we do Jada's, she ate 12 hot dogs in 5 minutes. So that is our constant of proportionality. So her hot dogs is going to equal 12/5 times t. There we go. That's all they want us to do is just write the equations that go with each of their situations. And remember, if we have each of these points, so this is the point 12/5, to find our constant of proportionality, it is just y divided by x. So we just do y divided by x for each person, and then we have our constant of proportionalities for them. The constants of proportionality for each of them means that's the rate they're eating hot dogs. They're eating 10/3 a hot dog for every 1 minute. I don't know if you can eat 10/3 a hot dog, but it's okay. Okay, so this is just a small review for the proportions. There's also the booklet that you can do, but you can go back, re-listen to the video, and redo the Desmos if you need to. If you do have any questions, just ask me next time you see me at school, and we can try and clear up anything that you're not sure about. Okay, good luck studying.